So next what we want to do is we want to practice solving circuits. Now you guys have done the basics of circuits, Kirchhoff's rules, you guys have done a little bit of Ohm's law, you guys have done combination of resistance, total resistance, and we're going to sort of piece all these things together and solve circuits. Now, one of the biggest things about solving circuits by far is they're sort of like puzzles. And it doesn't really matter what you're looking for, it's all about what you have. And one thing will lead to another. And for my lab doing this regular thing, I'd be giving you guys circuits and just telling you just to find stuff. And that's just what you have to do with circuits, is just start by finding what you can with what you're given, and eventually you can lead to what you're looking for. So we're just going to practice solving circuits and sort of show how this works. Again, some of this actually kicks back to grade 9 science as well, but we'll see what we can do. So let's just start with a basic circuit. So there's my power supply. This is kind of a thin. Let's make this a little bit thicker here. You know, it's better. Power supply, and we'll hook it up to some resistors. So there's a resistor, something like this. Okay, so if you remember, this is a series circuit because we got one path, and I'll call that R1, R2, R3, and let's say this is 10 ohms. Let's say this is 15 ohms, and we will say that this guy over here is 30 ohms. And let's say we've got a 200 volt power supply. Okay, so what we're going to look for is a couple things. So let's see, we are going to find out what is the voltage on number 1. We're going to find out the power in number 3. Okay, so forget voltage in 1, forget power in 3. What can you find with what you've got? Let's see, you've got the total voltage, you've got the 200 volts, and you have all the resistances. So why not find the total resistance? Okay, so it's just a series circuit. So all you have to do is add the 3 resistors together. We've got the 10, we've got the 15, we've got the 30. We put them all together. We've got 55 ohms in total. Okay, so can you do something with that? Well, you've got total voltage, you've got total resistance. You can find the total current. So the total current would be this is good old Ohm's law. So you got the 200 divided by the 55, and I can find the total current going through my system. And let's see, that should give me like around 3.64 amps. All right, there's my total current. Now this is a series circuit, and if you remember from series circuits, one of the properties of series circuits is the current is the same everywhere. So once I have that 3.64 amps, I mean that's the current coming from my power supply, but there's only one pathway, which means that's the current everywhere. So now I know the current here is 3.64 amps, over here is 3.64 amps, over here is 3.64 amps. I've got the current everywhere. And one of the keys is once you have 2 pieces of information for any part of a circuit, you can solve for whatever you want. It makes no difference. So I've got 2 pieces of information for R1, so now I can find voltage number 1. So voltage number 1, I'm going to use Ohm's law. That would be I1 times R1. And I like to try and do my calculations close to where the actual thing is. So I got the 10 ohms, I've got 3.64 amps, I just have to multiply them. So this would be 36.4 volts, will be the voltage across number 1. All right, R3, I wanted to find the power, and there's different expressions for power, but the one that would come nice here would be the power in 3 would be I squared R, would be the nice little combo. You can find the voltage there first if you want to use IV, it doesn't make any difference. But that's one of those shortcut versions that we derived earlier on. So I've got my current of 3.64. I'm going to square that and then times that by my 30. And we're looking around 397 watts. Okay, so that's what I've got with my little circuit right there. All right, so again, it's just a lot of it's about just finding stuff. What can you piece together, that type of thing. Okay, all right, let's get rid of this guy and let's try a different one. All right, let's try something like this. All right, so this is a parallel circuit. All right, so we got R1, R2, R3, something like that. Okay, so let's say you have R1 over here. Let's say this is a 20 ohm resistor, and let's say it's got 40 watts going through it. Okay, and let's say this is a 15 ohm resistor right there. Okay, and let's see if we can find, let's go with let's say there's 0.2 amps going through there. Okay, and we're going to find a few things here. Let's find out what is the, I'll change the color a little bit here. What is the current in number 2? And what is our number 3? Let's see if we can work with that. Okay, now once again, forget what we're looking for. Where can we start? Now there's only one place we can start, and that's where we have the most information, R1. We've got 2 things at R1. So we have to start there. There's no real other option. That's a great place to start. So I've got resistance and I've got power. So what can I find with that? Well, if I go back to the expression that we just used in the previous question, we had power is equal to I squared R. So I have the power and resistance, I can find the current. So the current in number 1 would be the root of P over R, and I could do that. Okay, so let's just see if that will help me with anything. Okay, so if I've got the power, I've got the 40, I've got the 20, so all I need is the square root of 2, which of course is around 1.4, 1.4 amps. Okay, now does that help me with anything? Well, not necessarily helps me too much. It's not a series circuit where the current is the same everywhere. I just know what the current is right there. So what else could I find? Well, I could find the voltage number 1. I could just use Ohm's law, I1, R1. You could also find the voltage using a power expression as well. Doesn't matter. So I have my I1 of 1.4 and I've got my 20 ohms. So if I just multiply those two together, I get around 28.3 volts. Now if you remember about my parallel stuff, in parallel all the voltages are the same. So if this is 28.3 volts, my power supply must be 28.3 volts, and all of these guys must also be 28.3 volts. And now I've got 2 pieces of information for everything. So that's perfect, so I can find other stuff. For example, I could find my current in number 2. I've got my voltage and I've got my resistance, so to go Ohm's law. So I've got that 28.3, so I just have to divide that by the 15 ohms. And we're looking around 1.9 amps going through that one right there. Okay, I could also go to the bottom looking for resistance 3. Okay, well, resistance is voltage divided by current. And do I have those things? Yep, I've got both of those things. That comes in handy. So if I divide those two out, I get around 142 ohm resistor at the bottom. Okay, so I've solved for the different things that I was looking for. Now we're going to go one little step further. Okay, I could also find the current in number 3. Not the current number 3. I have the current number 3. I could use the current in number 3, which is right here. So current 1.4, current 1.9, current 0.2. And if you remember in a parallel circuit, the currents have to add up. They split up, they add up. All in parallel circuits, they got to come together. So if I take that 0.2 and I add it to the 1.9, that's 2.1, and then I'd have 3.5 with 3 currents put together. So I've got 3.5 amps coming from my power supply. So if I've got the total voltage and I've got the total current, I could actually find the total resistance using those totals. So if I do the 28.3 and I divide that by the 3.5, we've got a total resistance of around 8.1 ohms. So that'd be the total resistance of my parallel circuit. Now sometimes, especially in parallel, this is an easier way to find the total resistance than using the other expression, because if you remember, total resistance in parallel, you would have to do like 1 over 20 plus 1 over 15 plus 1 over 142. You'd have to add up all those inverses and then inverse it. Well, you can do that, but it's going to be a pain in the butt sometimes. Sometimes if you've got the total voltage and total current, it's a lot easier to find the total resistance that way than is actually trying to piece it all together. Okay? All right, so there is a basic parallel circuit. Okay, so let's see if we can try a different circuit. Let's just get rid of all of this stuff. Wait, okay, so let's try something else. All right, so power supply, resistor right there. Okay, we'll do a little combination here. Maybe something like that. Okay, all right, there we go. Okay, so let's say this one here, we'll call it R1. All of our circuits had 3 resistors so far. Okay, so let's say this one right here has got 1.2 amps going through it. And let's say that one up here, let's see this guy here, let's say this has got 16 volts on it. And let's say it's a 2 ohm resistor. Okay, and what I want to know is what is the voltage of my power supply? Okay, what is R2 and what is the power in number 3? Oh, I forgot to tell you, we're going to say this one had 20 volts on it, something like that. Okay, that's a little better. Okay, so let's see if we can find our different things. So once again, forget what we're looking for. What can we possibly find with what we're given? Well, just looking at this section here, this is a parallel section right here, and I know that in parallel, voltages have to be the same, which means if I've got 20 volts here, this one over here must also be 20 volts because they are in parallel with each other. Now, I also have the voltage of 6. I actually have all the voltages of all my resistors. Now, remember, if I go around a circuit, all my voltages have to add up to the power supply. So if I start up here and come around here, there's 16 volts here. And I don't go through both of these. I can only choose to go one or the other. So if I go 16 here, I go this way is going to be 20. I go this way is going to be 20. I can only choose one or the other. So if I do 16 plus the 20, this must be a 36 volt power supply. Okay, I didn't even really have to calculate anything. I could figure that one out. Okay, so now that I've taken care of that, let's see what else we can find. Well, that resistor on the left, R1's got 2 things. So let's see what we can find here. Well, I've got voltage and I've got resistance. Current is really easy. Current is just voltage divided by resistance. So I got the 16 divided by 2. Well, that's just 8 amps. All right, so I've got 8 amps going through this thing, which means I had 8 amps coming through here because it's in the same line. All right, if I had 8 amps coming down here, I've got 8 amps. Well, I know 1.2 went this way. Well, if 1.2 went that way, the rest must have gone this way. So this one must have 6.8 amps going through it. Okay, well, hey, now I've got 2 things for each one, and I can piece things together. So R2 would be the voltage divided by the current. So I've got the 20, and I'm going to divide that by the 1.2. That must be a 16.7 ohm resistor. And for the power here, let's see, power, IV would work really nicely here. So I3 times V3. So we've got the 6.8 and we'll times that by the 20. And we've got about 136 watts altogether. Okay, so there we go. So again, it's all about just finding what you can find, and then, hey, do currents match up? Do voltages match up? What can I tell? What piece of information here can give me something over here? It's sort of like doing those puzzles, you know, those with all the curve things, all the numbers, all those, like they're Sudokus or whatever it is. If you've ever done a Sudoku before, you know, you find a value here and then tells you something about what the value has to be over here and this one, and one thing sort of leads to the other. Same thing for circuits. Just find what you can find. Hey, does that quantity have to be the same as that one? Can I add those 2 up to get this? Stuff like that. That's generally the way it works with circuits. And we basically just have to practice and practice and practice basic circuits and piece things together and treat them as puzzles, because that's literally what they are. Okay, so there's a few questions and practice questions on solving some basic circuits.